Hey, what's up, viewer? Welcome back to the Nebulous Live Development Creation Series. This is day 15, hour 1, but due to lapses in some work during the middle of the month, I actually have been working on this game for about a month, despite my 15th day of tangible effort being today. And it snuck up on me. I definitely wanted to get more done within the first month that I've got done. However, I still appreciate this series and its ability to keep me on track. And now that I'm focusing more on game mechanics again, I think I can continue the progress to a decent amount. Without further ado then, I am going to get back to what I was up to last time, which was essentially beginning to spawn stars inside of the nebula swans. So upon zooming in, the player needs to now have a view of a certain random number of stars in random positions, determined by the game starting up. And if I zoom out, then essentially it'll just zoom out back to the galaxy view. Long term, the plan is for the game to probably have the player start inside of their system, not inside of not start with the view of the galaxy, which would force them to scan into this notion. So whichever nebula they're in around this center, essentially they would have to scan out of that nebula to surrounding nebula. They wouldn't just have every nebula on the screen by default. And that would force the player it kind of forces the player to have different tiers of scanning. So they would essentially start at planetary level and have to scan out to greater and greater distances. And I suppose what I was considering last time was essentially, whenever this is complete, the easy thing would be to just instantiate them. However, I know that's not using object pooling, but I think for now that's what I'm going to do. So if I'm entering the selected nebula, and it might be freezing because oh, I guess it's back now. Okay, never mind. So more or less, upon completing the camera transition, or I guess technically they could instantiate during the transition. So I'm actually going to what I really want to do is consider instantiating, and it looks like I'm lagging just a little bit for some reason. The idea is essentially to instantiate a star. It's kind of weird though, because I suppose more accurately, this is kind of what this is what the actual nebula object was for. The idea was for this to, at runtime within its own bounds, it has to determine which objects or which stars it contains. And that might be based off of global data. but I have an idea basically on what to do. So let me see here. I'm going to generate a new mono behavior, and it's going to be called what should it be called here? So there's also okay, so a nebula. Okay, whatever. I'm just gonna use the straightforward approach, and I'm just gonna kind of work it in as a data, kind of a data container. So more or less, on start, I have to create an array of, and kind of, okay, so I'm a little, you know what, if I'm going to do ECS, I'm going to wait for the ECS patch, so I'm just going to work against ECS to a certain extent. I'm not going to worry about trying to do some kind of fancy integer key value thing. Instead, we're just going to keep it simple and say game object, and more or less this is actually nebula stars also, which is a little bizarre for accessing it. But essentially in start, we have to like come up with a random star count, and it's just a random dot range, and it's going to be an integer range. So now I'm trying to remember if I should. So now it's kind of like there's another system kind of that might be determining how random the galaxy is, but so it's probably just going to be a good idea. Give me 1 second, I just had some people show up here. Alright, sorry about that. Alright, so the idea here is to gather the player data, by doing this fancy call here, and then make sure I don't call it pal your data as I've done before, and I need to, I think it's Alt F12 to peek the data, and I've got to more or less add the data. Values that I'm considering here, which, let me see if I already have some that are like that. Actually, I don't see anything, so I'm just going to come right here and say public, and then we've got float nebula star density percentage, and it's going to essentially allow me to determine some float between 0 and 1. And I'll just make sure that it does that. And essentially that just allows for a global percentage of how dense the stars can be. But I'm getting the idea to have this randomly generated for each nebula. That way each nebula has a random density. So I'm not sure. The other thing is we've got public float or public int minimum nebula star count. This can force all nebula to at least have that many. Oops, and this is maximum nebula star count. And that's the same concept. You can cap the maximum number of stars in a nebula. And then this will more or less randomly pick I guess maybe this is, I don't really need this, because I can just plug these into the random and it's just gonna pick a number for it. So it'll just pick that it's got 6 or something. So I'm not even sure if I need this here. So I'm just gonna yank this out and see if I can make it work like this. So the idea then would just be to come in here and say player data dot minimum nebula star count, and then player data dot maximum nebula star count. And it is a random star count, but it is effectively so then we can say nebula stars equals a new game object array that is random star count dot length of that's just random star count. Yeah. And then we're gonna have to say nebulous, we're basically just gonna have to do a for loop. And for each nebula star, we would have to say nebula stars at I equals, and then we'll do an instantiation. And okay, so here's where I'm getting another player data-esque thing, but real quick, I need to double check something. So let me see, does the galaxy have a, I'm trying to remember, I know something has a, so star system perhaps, does this have a, no, it doesn't have anything. What about a star? If I'm not mistaken, I was doing this in a different scene somewhere. And I just had all the prefabs together here. So I'm actually kind of reproducing this to a certain other extent, but okay. So what I don't have though is on this assembly here. I don't have the collection aggregated, so I'm going to once again jump back into player data. I'm just going to have player data oops, I guess that's, sorry, I don't know, I'm getting picky on that. Basically just have a public game object array for star prefabs. Then run over here. And I'm simply going to grab all of these star types, although I should probably place them, I guess I can reorder them once they're in there. So yeah, I'm just going to fill this with all the star types. And star is synonymous with the yellow star, so I'm skipping that one in particular. But what, how many do I have for 1, 2? I guess it'll count it for me. Okay, I have to lock it first. So there's 8 of them, okay. And the order typically is so red supergiant, blue supergiant, red giant, blue giant, orange, yellow, red, white, in terms of size. So now we have now we just have one place where all the prefabs are stored. It's in player data, star prefabs. And I'm actually considering something where I actually don't know exactly what's more efficient. Honestly, if I really want it to be efficient, I just need to wait for ECS. So I'm sorry that it keeps like, there's always this anxiety that somebody's going to judge me for not doing it exactly correctly. So I apologize that I might stop and think about it every once in a while, but every once in a while, anxiety strikes. What can I tell you? Okay, so now that I've got this set up, essentially what I can do is come in here and basically this winds up kind of being the same concept, more or less. Like, there's an integer for random star choice, and we'll set it to 0 to start with. Oops, sorry. Random star choice. And then here we have to actually say random star choice equals random dot range, and the range just happens to be the more or less just 0 to, and let me make sure it's exclusive on the end. So the idea would be to go from 0 to player data dot star prefabs dot length, and that is going to give us a random choice for here, where we can then say instantiate, and what we're instantiating is the player data's star prefabs at random star count, or excuse me, random star choice, which I have to properly assign here. I named it incorrectly. So random star choice, and that is going to instantiate on start of the nebula the star object inside of it at a random position. Or actually, excuse me, that's not correct, is it? It in fact is not a random position. It is at this point just instantiating at its base position, which is 0 of the galaxy. So it has to, darn it, I guess I'm gonna have to write a function here. Oh, I guess it's a nebula. This is only on each nebula, I guess. However, it's not, whatever. Once again, sorry, the criticism. Ugh. It just feels like somebody who just happens to know better, just because, is, this is always what I feel, is that that person's like looking over my shoulder and just calling me an idiot for not doing it exactly correctly. And anxiety strikes pretty easy. So For now, though, I'm going to just do it at a high level. The efficiency can come once ECS shows up. So that's a lot of the efficiency I would make into the game is essentially what ECS is providing anyway. It's just certain structuring of the data. So I'm just going to wait for that. And if I really need to throw some, if I really need to, I can throw some job systems at this thing anyway. And if I really need to, then I can also make coroutines or something. So there's high-level options for dealing with efficiency issues, even though it's not the most efficient code possible. All right, so something needs to happen here, and that is that we need to gather a vector3 for the vector3 generate new start position, more or less. Vector3. Actually, since this is part of the class, well, I'll just have to return it. I don't know, can I actually do this? Sorry, this is experimental here. I can do that, look at that. And I just I'm not worrying about efficiency, but this is a pretty simple one. If I could just cache this. I understand how caching works. So vector3, we'll call it new start position. And I'm actually going to throw this up here. And then we can then return. Oh, it's not going to let me, unless it's global. Okay, fine. So we'll throw new start position up here. And then more or less, we are actually instantiating the object at generate new start position. And the quaternion is just identity, and the transform is actually transform. We are going to parent it to the, or we're going to child it to the nebula. So the nebula stars object. And then generate new star position is a little bit more involved. And because it's so specific to this, I'm going to move it down here, because now I'm going to have to create a couple other things as well. So I'm going to need so generate new start position. I'm going to need a vector3, which I don't actually need to do that because I can just grab the transform. So I can at least say transform.position. And automatically now they will all spawn at least on top of their own nebula. Or not on top of it, but at the center of it. As long as it's centered positionally and not by the corner. So the next thing that needs to happen though is there have to be a few things that happen. The position more or less needs to be multiplied by vector3.forward, and this is going to create a vector that I can rotate, and I want to rotate that vector in a couple of ways, or okay, so this is one way I can do it using a radial emitter, but I can also, if I don't use a radial emitter, there is very, very obvious linear randomosity. So like it's just, there's very, very obvious spots where like certain quote-unquote random things are actually perfectly in line with each other, which is not correct. So I've got to use a radial emitter to give them more random positioning. Okay, so that means I'm also going to need like a random something like this. And this is going to wind up being a random value. But, in fact, it doesn't have to be a random value. Yeah, no, the easiest thing would be to just make a grid. There's just there's like a million different patterns you could use, really. It could get chopped up into square regions, and you could just have a random position inside of each of those regions with a random chance for each region to have a spawn. I guess that's not a terrible idea. So for something like that, I would need to say like vector 3 nebula. I guess I don't have to do that because I already have that available here. But essentially the scale needs to get chopped up into, ideally it can get chopped up into cubes somehow. So like you're taking this and you're saying I guess, okay, so then I guess it's actually like there's an integer for like X resolution. Basically. And I guess I'm hard coding these for now. 10, 3, and then 10 again or something. And it will basically, this needs to get divided by like X resolution. And this is going to provide basically an incrementer. I basically do the same thing for these next two lines. And this is going to give us the total size of each box the total size of each rectangle, basically a box. It's not a perfect cube, but they're boxes. And you essentially get a bounds to randomly spawn within. Although for some reason it is not coming too easily, so I'm wondering why I'm not too confident in this. Maybe I need to make the resolutions global. Okay, so I know I'm on the right track with this somehow, but I don't like hard coding these resolution values at all. But essentially what we have is, oh, and does that have to be multiplied by 2? Actually, I can't remember that, if that's true or not. I think technically this takes up a singular block. Okay, so a cube at 1, 1, 1 is actually centered by default anyway. But its scale is 1. So I don't have to do what I was thinking. So I might not be using a quaternion. It's basically like the starting position of the nebula center, and then minus half of the x value, half of the scale. Transform to local scale to, oh, I spelled it wrong. Scale to x divided by, whoops, not lock, divided by 2. And you basically want to subtract that from transform dot position dot x. And this is effectively this is like a vector 3 that is x, it's like x bound position or something, which means I think I might be able to grab I thought maybe I could do that. I think I might have to use the mesh for that. But the idea would be that basically something like this, but if I do that for the other letters, and it doesn't even like that I'm doing it either. So this is actually a float. The idea would be to get a y and a z for this, and then that gives like a far corner kind of thing. If you subtract half of the z and half of the x, it will be halfway, and you subtract the y. That'll be like the back bottom corner, basically. Or the actual position of the back bottom corner. And then the far position, which is essentially the same math, but you're adding the z value, not subtracting it, will give a total. Oh, and then that value divided by the like z resolution will give positions. And then if you do the same thing with the other values, you more or less have like a box of boxes. And you have to then take random positions within those boxes. And you can more or less make sure that the stars spawn in random positions, but positions that are to a relatively controllable degree. Well, if they're in nebula space, as long as there's like a solid buffer value placed within the spawner, even if things get close to the edges, a giant star will still be pretty far away from even another giant star. Though I don't have to deal with any cases of them being like right next to each other, I don't think. Even though they'll be close in terms of like interstellar space or whatever. And that basically has to happen right here. Okay, so we're looking at like a so like I said, we're splitting it up by these resolutions. And then we have to do a triple for loop from 0 to resolution sizes. And then we do an increment of the positional values, which is just the base increment times the x, y, or z value. And then we could basically pick a random percentage to add to the space base value and use that as the position. And we can also add in like a buffer value so that they always spawn within like, or they always spawn at least like maybe 25% of the volume away from the edges or something. to that way we don't have random spawns that are right next to each other in terms of the box space. Alright, so let's go show I'm going to need to globalize the resolutions, but I could also randomize the resolutions, to be honest. And you can get different kinds of spawning patterns. So if I want that, I could do that later. So for now, I'm actually going to remove the... I'm just going to reduce these to 4 and 4. Which is still, 12, 36 iterations. But then I have to say for Z resolution, or Y resolution, or X resolution. And inside of here we have to... Oh, actually, no, wait, hold on. Okay, so the way I'm thinking about it now is this loop actually has to be like up here, because we're no longer spawning for each nebula star like this. We are instantiating every star at a particular position. So I guess what we could do is we could maybe generate an array of positions. So more or less we would have to so there's kind of a different way I'd like to do this actually. More or less I would like to run a float value for, well, I guess maybe that's not the right place for that. Man, okay. So let me just drag this up here, because I'm rather sure this is where it has to go. So if we're doing something like this here, the idea is that we can use this algorithm to pin but it's only if a random number is, or it has to do a percentage check basically. So like there's some percentage. Okay, so and then essentially this is what I was doing in player data to a certain extent, was a random spawn percentage, but let's say random nebula density, star density. And this just equals random.range. And once again, we're looking at like a player data value, because we want to use player data as the basically, so minimum nebula star density, replicant maximum nebula star density. And we more or less use that to seed these random values. So I can make it, I can force it to at least have at least 5%, but never be all the way up to 100% at the same time. And I can just kind of do randomosity. And then within here, it's so if a random.range between 0f and 1f is greater than random nebula star density, then we in fact do want to generate a position. Which is determined by a few values. Which is actually making me want to basically move all of these to player data also. Or I can randomize these basically. So random.range, integer range. And it's the same thing when you like a player data min-maxing. So pull this back up here. Minimum nebula X resolution. Maximum nebula X resolution. And then just change these to Y and change these to Z. And I'm very likely gonna have to add a collapsible region for all these in the long run, but we'll see what happens. So now I just come in here and I can just let them be random by design. So we're getting back into basically saying, let's see, trying to think of an efficient way to do this. Random.range, and we're saying player data dot and then we are saying, I'm trying to remember what it was. It was an integer range. Minimum nebula X resolution. Yes, okay. Sorry, somebody's knocking outside the window. Might be my nephew. Minimum nebula X. And it's an exclusive range on this one, so here it's like we have to say maximum. Oh, wait a minute. This one's actually Y, my bad. This one's nebula Z. Sorry, this is a little janked, but it's kind of pretty rote, so. Once again, we're just looking at player data. This was looking at maximum nebula X resolution. but it's exclusive. Ah, whatever. It will work anyway. For the values I put into it. Maximum nebula Y resolution. And then maximum Z nebula Z resolution. Okay, so now the resolution is also randomized between some kind of variable range. And that allows it to feel a little different in terms of where the stars are at, so I think it helps. It also lets me reconvert the system later. Or it lets me change the... It allows me to kind of force the densities to certain values if I need to. Okay, so now we're looking at the fact that we now have the Z resolution, Y resolution, X resolution. I'll have to make sure I intuitively remember how this randomness works, but if this randomness says true, then it's an instantiate, or at the very least we have to create a position, right? Vector 3 new position equals and here's where we're kind of looking down here at stuff. So I'm pretty sure I'm going to need float X increment, float Y increment, and float Z increment. And these are equal to, so the X increment is scales the whole thing, right? So transform.local scale dot X divided by X resolution. And this is effectively giving us increments that is based on the randomly, well, potentially randomly decided scale, but all the scales are actually the same, if I'm not mistaken. Since it's prefab, it just gets, this allows the increment to be resolution. Resolution, my bad. Okay, so now I have these increments. And effectively, so okay, so vector 3 near, or hold on. Okay, so this is a good point because now that I'm thinking about it, if the Well, hold on. Okay, now I basically have to sequence them properly. So we're looking at like, dang it, hold on. Darn it. I feel like I missed something here. So even though I have these increments, the problem is that it's starting from the center. So it's like half of the increment or something. Or the increment only needs to be half of itself and then shift between positive and negative or something like that. Like, because if we're starting at the center, then sometimes it's... Well, okay, so maybe what I could do is just say transform... Whoops, hold on. Okay, so I'm thinking like transform.position .x minus... So then we're turning it into a new vector 3 anyway, right? We're doing something like transform.position.x minus x increment. But that's not exactly correct either. It's really something like this. So half the scale. So this is like starting vector or something. And it's basically just doing the same thing in all of these positions. This is effectively giving us the near bottom corner, which is just where the pattern can start from. And if the pattern starts from the near bottom corner, then... Whoops. And the starting vector is basically the same. For each nebula. And maybe change starting vector to say, let's be a little bit more descriptive. So instead of starting vector, it's like, what is it, like starting vector of what? Star spawn starting vector. And I'm almost out of time, but I'm going to try and squeak in maybe another line here. So star spawn starting vector. Essentially what this allows us to do is take the starting vector, and at each new position that's chosen, what we do is we effectively say plus x increment times x. And is this, what is this, a floating point value? Okay, yes, so we're looking at like float new x new y and new z. And then from this, it's like vector 3 new position equals new vector 3, new x, new y, and new z, oops, new y. Oh, my bad. What? Okay, I just spelled it wrong. My bad. Oh, I see why too, because I changed them all to be lowercase. Alright, so now I feasibly have the new position, but it's not exactly true. What I have is the starting position based on. Just leave it like that for now, it's clear enough. Alright, so I'm gonna end the video here. It's starting to look at like something that could really get run through the job system possibly really good. If I could sort out, if I smush this to a single array, I could do a parallel job. But I'm gonna wait and see if it actually needs that or not before I do that. Because this is running for each nebula on start basically, but the idea is that the player only finds a handful of these nebulas over time anyway. However, for AI to spawn, there will need to be, each nebula is going to have already spawned its planets, or at least in data it has to. It doesn't necessarily have needed to instantiate the game object specifically, but the object needs to exist enough so that it can be run through a system that chooses where NPCs spawn, essentially. And then it picks NPC starting positions. So it'll have to evolve anyway. But for now, the next step for this is I just have to add a random percentage of the increment to the starting position of all three types. And more or less that will give the starting position plus a random position within the square. That's basically, or within the cube. That's basically how this is going to work. And I can even add the buffer values here, and that will make sure that you don't get weird spawns where like a big star's at like 99.9% and right next to it is another star at like 0.01% but in a different cell. Because that's going to probably put the stars too close together, but depends on the scale. Let's see. So sorry that I kept rambling on here, but the system's actually getting pretty close to being done, so I'm excited to see what happens. Alright, so that's what I'm going to be working on in the next video. Thanks for taking a look at this, and take care.